there were many great use cases for data, but the computational resources did not exist, and nor did the experience in actually mounting and doing proofs of concept, as is always the case with some of the more advanced, let's say, machine learning techniques or predictive techniques required so much data and so many cycles of compute in order to hone those and prove it. And now, because of compute resources, you can actually get to market more quickly with those innovations. Are you finding that in terms of digital transformation in the energy industry? Are you seeing new approaches or applications of data that didn't exist before?
Absolutely. I'll give you two examples from oil and gas industry. We do what is called property modeling in the seismic domain. And typically in traditional ways, it would take months to analyze the data. With actually combining it with the science and then combining data or integrating data, as I call it, and then building multiple algorithms on top of it, one can actually reduce that months to hours. The goal eventually, everybody talks about digital twin, that maybe one day we would have what I call geophysicists, maybe like pilots. They wait for the results and then only do things when it's really needed. Right now, most of the things are done manually, trying to figure out where the oil is, kind of manual, right? One can actually make it more automated. So where three things that we do is either we automate using algorithms, or we optimize, or eventually we innovate solutions. And that's how we think about it. And the second example is like when, say, drilling process happens, this whole planning scenario is done, right? I think you asked something about that. And that takes months and months of work. But with connecting data from contracts, connecting data from field, connecting data from geophysics, you can actually now reduce that planning process significantly. And any savings could be really a significant amount of saving for the industry. I don't know if you read, there was an article, I think 2 years ago from Capital One Bank or one of these banking person, that that oil and gas industry, not the service companies, but more on the operator side, they were talking that that there has been a lot of capital loss. And if you think of it, if we can reduce any of these, either automate anything or we optimize something, we can actually reduce that capital loss.
Oh wow! Right. That's a good way to think about it. So this leads to another question then. So you've made advances in data science, and you're in an industry that's in transition. So right now, how are some key decision makers using data and insights at Halliburton? Any best practices you want to share?
Yeah. So for us, we have been on a really journey. In fact, if you look at I think 2017 or something, one of the comments our executives made that we have a digital as a part of the core strategy, and that has been our mission and a goal. So digital is no separate for us than our traditional business. Digital is part of the core strategy. So as a result, everything that we do within the company has a digital footprint. And Halliburton is a much larger company. So there are different business lines that are there, and each one of them have their own challenges and their own maturity level in terms of leveraging the digital technology, because some are very complex, some are much simpler, but everyone is actually doing everything digital. So data driven is the foundation aspect for what we do. So for all decision making is, as I said, I always use the word augmented with science and engineering and data, because you can't isolate.
I love that word augmented, and I like to think that back in the 1950s when John McCarthy and that group got together to come up with the initial founding documents, and they called it artificial intelligence, that we would have avoided a lot of stress and anxiety in the world and in the community if we'd have just called it augmented intelligence rather than artificial intelligence. Far less scary and actually more suitable to the way we use AI right now. if we look at, and this helps me digress to what everybody always is interested in when they meet people like you, and that is, tell me about artificial intelligence. And they're either scared of it or they're super excited about the promise of it, right? So one of the things I like to talk about is compensating for AI bias in all its forms. And as a data scientist, you know what I'm talking about. To the layman, AI bias is it going to make a prejudicial decision related to societal outcomes? That's one way. But as a data scientist, you know that there's many forms of data bias. Talk to us a little bit about AI bias and how you can prevent it in terms of these massive data sets and the importance of getting it right in a business like yours.
So first thing, one thing I try to clarify, there's AI is just an umbrella term. Let's not confuse it.
Yeah.
Right? When the founders or the creators talked about it, they also knew it was an umbrella term. It is all various marketing people have changed into as if it is something you can take it in a box and deploy it.
Right.
My analogy to that is that we never say that we are wearing chemistry, we are eating chemistry, right? We are using chemistry to clean the table, right? They're all part of chemicals. And so we say we are clothes, we are eating food, or we are using chemicals, cleaners to clean the table, right? But we never use the word chemistry. So let's be very careful about how we use the term AI. Now, having said that, these are the algorithms that are what are causing the bias, how those algorithms are created on what kind of data, that's what creates the bias. So if I on purpose do not include certain features in the data, your results are going to be biased. So the question is, have we thought out of our holistic picture of a workflow? If we think of holistic picture and you have all the features associated with that workflow, then the biases automatically will reduce, right? So one of the things to do in an operational setting is to think about all possibilities of what data could be used. That doesn't mean that you need to collect all the data from day one. You have enough of historical data in big companies or big industries. Start with that, look at how the results are, and saying, oh, if only I had this kind of data, then I could probably see something else. So you keep building, you keep adding more and more dimensions to the data, so your pattern gets more holistic in nature. And when there is, eventually we all know that most models reach asymptotically a limit when it flattens, and you cannot improve anymore. Then you know that you've exploited either all the feature sets or you've exploited the possibility of all the values of the data. That requires investment. The challenge is that companies don't want to invest that much to come to that limit. And hence they are left with models which have biases in them.